Hello students, welcome back to the discussion of the chapter Electrochemistry, and we are continuing our discussion with respect to the numericals of Gibbs energy change and equilibrium constant. So let us consider one such question here. Consider the following cell. The cell is there in front of you in which lead electrode is anode and copper electrode is cathode. We are supposed to find the delta G and delta G naught for the above given cell, and we have been given the E naught values of lead and that for copper. So E naught PB is minus 1.26 volts, E naught copper is 0.34 volts. Alright. So here, to find the value of delta G, we first need to find the value of E cell. And for delta G naught, we'll be finding the value of E naught cell. Okay. In either case, we will be needing the cell reactions. So let us first of all write the cell reactions. So at anode, you have PB getting oxidized. So PB solid gives us PB2 plus ions plus 2 electrons. And at cathode, you have copper ions getting reduced. So Cu2 plus ions aqueous plus 2 electrons will give you Cu solid, right? So overall reaction here would be PB solid plus Cu2 plus ions aqueous giving rise to PB2 plus ions aqueous plus Cu solid. So for this particular reaction, if you want to write the Nernst equation, it would be E cell, which is equal to E naught cell minus 0.0591 upon 2. Value of N here is 2, right? Log to the base 10 concentration of PB2 plus upon concentration of Cu2 plus. So let us first of all find the value of E naught cell. E naught cell is precisely E naught oxidation plus E naught reduction. So here PB is getting oxidized, so that's why we will write its oxidation potential. And for copper, we will be writing its reduction potential. So it is 0.126 plus 0.34, which gives us the answer as 0.466 volts. Okay. So now we can easily find E cell, which is equal to E naught cell minus 0.0591 upon 2 log to the base 10. Concentration of PB2 plus is 0.5. Concentration of copper ions is 0.001. Alright. So here substitute the value of E naught cell as 0.466 minus 0.0591 upon 2 log of 500. So on simplification, we have 0.466 minus 0.0592 upon 2. Log of 500 is precisely 2.689. So going ahead with the calculation part here, the answer for E cell we get is as 0.3863 volts. Okay. So once we have got the value of E cell, we can easily find the value of delta G, which is minus NF E cell, isn't it? So substituting the values, minus 2 into 96500 into 0.3863, which gives us the answer as minus 74,555.9 joules, which is precisely minus 74.55 kilojoules. So that was the answer for delta G. Also for delta G naught, we have minus NF E naught, right? So again here, minus 2 multiplied by 96500 multiplied by 0.466, which gives us the answer as minus 89,938 joule, which is precisely minus 89.938 kilojoules. So I hope students you got the idea about this particular numerical. Let us have another numerical here. We are supposed to find here E naught cell, E cell and delta G for this particular reaction at 25 degrees Celsius. Magnesium is getting oxidized to Mg2 plus, Sn2 plus ions are getting reduced to Sn. We have been given E naught magnesium and E naught Sn as minus 2.37 volts and minus 0.14 volts respectively. So here we know that the standard potential of tin half cell is greater than that of magnesium half cell. So it is quite obvious that Sn electrode would be cathode and magnesium electrode would be anode, right? So now let us first of all find the value of E naught cell. And we know that E naught cell is equal to E naught oxidation plus E naught reduction, right? So substituting the values here, 2.37 minus 0.14, which gives us the answer as 2.23 volts. Okay. Now, once we have found the value of E naught cell, we can easily find the value of E cell, isn't it? So, E cell here is equal to E naught cell minus 0.0592 upon 2 log to the base 10 concentration of magnesium ions upon concentration of tin ions, right? So E naught cell we already know it is 2.23 and also the concentration of magnesium and tin ions. So we substitute the values here. So 2.23 minus 0.0296 into log to the base 10 0.04 upon 0.03. So again, here you have 2.23 minus 0.0296 log to the base 10 1.33. So we find the value of log of 1.33 here. So we have 2.23 minus 0.0296 multiplied by 0.1248. So eventually what do we have here is 2.23 minus 0.0037, which gives us the answer as 2.226 volts. So again, finding the value of delta G. Now we have already found the value of E, right? That is E cell. So substituting the values for N, F and E in this particular formula, we have minus 2 multiplied by 96500 multiplied by 2.226. So eventually the answer here we get is minus 4,29,600 joules, that is minus 429.6 kilojoules. So that was the answer for delta G. Alright. And also here we can say that the EMF of the cell is positive and delta G value is negative. That's the reason we can say that the reaction would be spontaneous. So I hope students you have got the clear understanding of this numerical as well. Thank you.